This is Research Like a Pro, episode 264, the Alford Johnson Project, interview with Michelle Mickelson, part 3. Welcome to Research Like a Pro, a genealogy podcast about taking your research to the next level, hosted by Nicole Dyer and Diana Elder, accredited genealogist professional. Diana and Nicole are the mother-daughter team at FamilyLocket.com and the authors of Research Like a Pro, a genealogist guide. With Robin Worthland, they also co-authored the companion volume, Research Like a Pro with DNA. Join Diana and Nicole as they discuss how to stay organized, make progress in their research, and solve difficult cases. Let's go! Today's episode is brought to you by findagrave.com, the best place to search online for burial information for your family, friends, and famous people. At Find a Grave, you'll find details about cemeteries and individual memorials for the people buried in those cemeteries. Hello, everybody. Welcome to Research Like a Pro.
Hi, Nicole. How are you doing today?
Doing great. How about you?
I am doing well, just doing my thing. I think it's always fun to have a little break from the busyness of fall, winter, and spring, right? And just to enjoy summer. So, still having to do work, but it's great.
Yeah.
Well, for our announcements today, we have our Research Like a Pro webinar series. Next webinar, which will be on Tuesday, August 15th at 11 a.m. Mountain. And the title is Surprise, My Great Grandmother Was the Milkman, a DNA Case Study. And our presenter will be Ruth Campbell, who did one of our very first Research Like a Pro study groups. And it was so fun to meet her, and it's wonderful to see that she is now teaching so many people herself how to research. Our next Research Like a Pro study group is this fall and goes from August to November of 2023, and registration ends on August 10th. So that's wrapping up quickly. If you're interested, if you've been on the fence, it's time to jump in and join us. And if you're interested in being a peer group leader, that application is on our website. And then join our newsletter for coupons. We are looking forward also to another conference, which happens in October in Salt Lake City and online. And this is the Association for Professional Genealogists conference. It's called the PMC, Professional Management Conference. So if you've been thinking about doing professional work, or you already are working as a professional, that's a really fun conference. It's quite a bit smaller, and the classes are all geared towards professional work, and Nicole and I will both be there in person teaching, so it will be really fun.
Yes, I look forward to speaking at that conference with you. It'll be fun. Well, today we're back for part 3 of our interview with Michelle Mickelson, and she was the researcher for a client project that our team worked on, the Alford Johnson Project, in order to prove that there was a name change and a gunfight that caused the name change. So far, we've kind of gone over the oral traditions and the documentary research. And then today we get to introduce the DNA evidence and see if that supported the conclusion. So this should be a fun episode.
Hello, Michelle. Glad to have you back.
Hi there. I'm super excited to be back. This was the most fun part. It was all fun, but this was a really fun part too.
Great. Well, start us off with telling us what DNA did you have to work with?
James William Johnson's great grandson with the same name, he descended through James and Sarah's son, Charles Parker Johnson. So for this podcast, I'm going to refer to James the second as JJ, because there's a lot of James and I don't want to confuse anyone with all the other names of the project. So JJ tested at 2 companies. His Y-DNA was tested at Family Tree DNA, and his autosomal DNA was tested at Ancestry DNA. So for Y-DNA, a father only shares Y-DNA with his sons, and Y-DNA changes very little, and this makes it useful in tracing distant relationships along the paternal line. And because of its stability, I used Y-DNA to test the hypothesis that James William Johnson was born Patrick Alford. For autosomal DNA, a father and a mother both share half of their autosomal DNA with each child. This type of DNA is useful in determining more recent relationships along both the paternal and maternal ancestral lines. So I used JJ's autosomal DNA results to support the now documented family relationships.
It's nice that you had both Y-DNA and autosomal. That's great. So tell us, how did you analyze the Y-DNA?
Y-DNA can link different surnames together and help sort out family relationships. And since Y-DNA can only pass from a father to his son, tracing the direct male line provides biological evidence to compare with the documentary evidence. So in America today, we're more familiar with surnames that are passed down from a father who got that surname from his father, and so on. And so, what happens if, as in this case, a father decides to change his surname? So, I reasoned that a father could decide to change the documentation, but the DNA should remain the same. So, in the case of James William Johnson, the Y-DNA carried by his descendants agreed with this logic. And so, when I analyzed the surnames in JJ's results, I noticed that no Y-DNA match carried the Johnson surname. This was a big clue that validated a break in the paper trail. This lack of evidence also disproved the possibility that Patrick's mother, Alcy, married or had a misattributed paternal event with a Johnson male. In contrast, I observed many Y-DNA matches carrying the Alford surname, providing biological evidence to prove reliability in DNA. So I then examined JJ's Y-DNA matches, and closely related Y-DNA matches are part of the same haplogroup. A haplogroup is just a name given to a large branch of the genetic human tree. So JJ's haplogroup, RM269, is very common, but it does point to an Alford connection. And the ideal Y-DNA match compares the same number of markers within a relatively close time frame to track down a common ancestor. So using 67 markers and a genetic distance within 3 steps can locate an ancestor within 4 to 8 generations, which is pretty remarkable because Y-DNA just goes on forever. And so to be able to narrow it down to that genealogical time frame is really useful for DNA research. So this fit within the genealogical time frame to test this hypothesis of a biological relationship with the contemporary Johnsons and the distant Alfords. So it kind of brought the two together. So in JJ's results, a 67 marker comparison test revealed that 27 Y-DNA matches shared the Alford surname. 22 of those men were within a genetic distance of 1 to 3 steps, which is really fantastic. And 18 were in the same haplogroup, the RM269, and 0 matches had the Johnson surname. This was a big indicator. So I selected 4 matches who stood out. And one of the ways that genealogists can share case studies like this is by protecting the privacy of other DNA testers and their matches. So I renamed them. Very original names: Anonymous A, Anonymous B, Anonymous C, and Anonymous D. Anonymous A had a genetic distance of 2 steps, and his earliest known ancestors showed Charles Alford, who was born 1790 and died 1858. So this time frame fell within range of that 4 to 8 generations from the tester JJ, and lines up also with the documentary evidence. So I made a diagram to illustrate the documented paternal lines of JJ and Anonymous A to this Charles Alford, and that can be seen in the blog. But basically, I just went by generation and at the 5th generation is where that connection was made to Robert Alford with this anonymous match. So that checked out within that predicted range of 4 to 8 generations. So with the other 3 DNA matches, I noticed other similarities. So this is with anonymous B, C, and D. They shared also the Alford surname. They were in the same haplogroup, and they had the same genetic distance of only 1 step. So this was a really good sign. Family tree DNA has a great tool called the Y-DNA tip report. It showed me a roughly 90% chance that JJ and these 3 matches shared a common ancestor within 4 generations, which is right about the Patrick Alford, James Johnson timeframe. And that percentage rose to nearly 99% within 8 generations. So this was very strong evidence for an Alford connection. And of course, I had to put all of these fantastic details in a table that you'll be able to see in the blog. And I just matched the names on the left, compared the surnames with the haplogroup, the genetic distance, and then the probability at 4 generations and 8. And it just makes it really nice to be able to see all those numbers and compare them in a small space.
Yes, wonderful table. I love that. Amazing number of matches that appeared when the test taker took his Y67 test. I mean, 27 matches with the Alford surname. I think everyone out there who has taken or has had someone take a Y-DNA test is wishing their results would be that awesome and
Right?
conclusive.
Amazing.
It really is. I remember when I was first talking to JJ and his son James, and I said, "Have you done the DNA testing?" And they said, "Well, we thought about it. We weren't sure what to take." And I said, "Well, you definitely need to do that Y-DNA because that's going to show that paternal line." And then autosomal, of course, is very valuable because then you find all your cousins. And so the two of those work together so well in providing proof. So they also did the ancestry autosomal DNA because there are so many people in the database there. And so what did you discover when you analyzed the autosomal DNA?
Well, if Y-DNA was like finding a birth certificate naming the parents at Family Tree DNA, then autosomal DNA was like finding the death certificate naming the same parents on Ancestry. So JJ had a lot of autosomal DNA matches on Ancestry that descended from multiple Alford generations. So it just added, another layer of evidence to this case. A little bit of DNA background. Everybody inherits exactly 50% of each parent's autosomal DNA. And beyond that, it goes half at each generation. So 25% from grandparents, about 12% from their great grandparents, and 6% from great greats, 3% from third greats. So the difference with DNA is the inheritance is a random process. So everybody inherits a little bit different amounts from different ancestors. For example, second cousins will always share DNA, but the amounts will vary. The third and fourth cousins will not always share DNA, even though they are genetically related. So this can be a little bit confusing sometimes to grasp at first, but a genetic relationship is measured in units called centimorgans, and a testing company basically applies probability to the total number of shared centimorgans to predict how the test taker is related to a DNA match. So their relatedness correlates with average and range. So in practice, when we look at the number of centimorgans a DNA match shares, we expect that number to fall within a predetermined range based on the known or the theoretical relationship. And so the DNA painter charts, and there's so many wonderful tools and researchers that have provided numbers and charts that we can compare this information to. When the number of centimorgans falls within that expected range, this is a good sign that the DNA match is relevant, and then we can safely proceed with our research. So I chose the most relevant autosomal matches for this case and moved forward with them. There were a lot to choose from. This is a big family with lots of siblings,
Right.
children, so.
And I think this is such a good illustration about how you prove an ancestor, whether you're trying to prove, someone that changed our identity or just simply proving a great grandfather, first, second great grandfather, whatever relationship you want to prove, that you really do take it step by step. And I think that was a really key word that you used, relevant autosomal matches. You didn't need to use everybody. Let's get the ones that are the best and really can help us.
A word from our sponsors, Find a Grave. Find a Grave makes it easy to find the graves of ancestors, create virtual memorials, and add photos or virtual flowers to a loved one's memorial. You can search by name, location, cemetery, date, and more. Find a Grave members add more information each day, so if you've searched the site before without finding what you were looking for, come back and check again. Looking for a way to give back to your community? Download the free Find a Grave app, visit your local cemetery, and add missing grave information to the site. It's an easy and fun way to spend some time outside and help other people who are searching for their family and friends. Find a Grave is completely free to use, so start your search today at findagrave.com.
Well, Michelle, we've got to talk about how you organize this autosomal DNA data, because you were going to be putting this into a report that would be shared with family members. And you couldn't just say, well, the autosomal DNA showed a bunch of Alfords, so they're definitely connected. Much as we wish we could just say something like that, we have to get it down in a way people can digest it, but that also really shows the proof. So, what did you use?
2 words: tables and diagrams. DNA is just a bunch of numbers, dense information about relationships that can really be a challenge to explain to any client or average human for that matter with limited background and understanding of DNA. So, to simplify this complex information for the Johnson case, I organized 19 matches in a table and color grouped them by most recent common ancestor, or MRCA. There were 5 couples represented in this study. So for the blog, I anonymized the DNA match names according to the sibling lines of each MRCA couple. Having these details available in a table helps to just quickly verify that each match shared amounts of DNA within that predicted range we talked about. So, using the information in the table, I then created diagrams showing how each match was related to the tester, JJ. This helped me visualize the relationship so I could accurately check and compare amounts of DNA. When we're learning our own families, and especially as a genealogist, when we're learning other families, it helps so much to just get them all in front of us on a diagram, and we can count generations to make sure that they're in the right place and sharing the right amount of DNA. So through lines is my favorite tool to get me started with diagrams. That's really helpful to use as a starting point. So it's important to remember that Ancestry Through Lines uses self-reported tree information to identify the MRCA couple. I always do a quick check. The Johnsons had a robust tree. They had good sources attached and a lot of information filled in. So I felt like it was a reliable way to begin. So I went ahead and used the tool to gather DNA matches that descended through each couple represented in the study. So my process went something like this. I selected one match from each sibling line who shared the highest amount of DNA with my client and tester JJ. I recorded their details in my table. I included the match's name or ID, their relationship, the most recent common ancestral couple they descended through, the sibling they descended from, the centimorgans, shared average centimorgans for that relationship, and then the centimorgan range for that relationship. And this is shown in the blog. It's lots of numbers, so don't be too scared. To kind of help break up this table of 19 matches, I colored each MRCA group. So for the Johnson Andersons, I just left in white. Then the Johnson Clarks, I shaded in gray. The Alford Evans were in blue. The Alford Tiptons were in green. And the Evans Parks were in, I believe on the blog post it shows pink. And for some reason it showed up yellow on here. But so if I go back and forth between the two, that's why. I created diagrams, and I like to use Lucidchart as my preferred tool for drawing diagrams, but any tool works, pencil and paper, just anything to get a visual. Then in my report narrative, I cross-referenced each diagram with the corresponding color in the table. So it's a lot of back and forth, but it is tricky to try and coordinate that information in a way that can be understood.
Yeah, it is. I think we're always struggling with how to get DNA into these tables and diagrams in the best way possible. So I really like what you said about how you used through lines and you verified it, and then you were trying to get the best match from each one of the sibling lines. That's so key to make sure you're getting all the different independent lines coming down from each most recent common ancestral couple. So good job doing that. That just gives you such a nice scope of the DNA that's being examined.
Yeah, there were a lot of that. That was just so neat to see all those lines, that width of autosomal coverage.
Right.
And how great to use color in your table. I think that worked really well. So tell us, what did you learn about the Johnson Anderson family connections?
So 4 matches descended from James William Johnson and his first wife, Sarah Jane Anderson. All of the matches shared an amount of DNA within the predicted range of second cousins. So I named each one after, because they were a descendant of James, and just did like a 1, 2, 3, and 4. So James 1 shared 135 centimorgans, James 2 shared 177 centimorgans, and James 3 shared 169 centimorgans, and James 4 also shared 169 centimorgans. So although each match was below the average of 229, they all fell within that range. So then in my report narrative, I cross-referenced this diagram with the white group that was in the table. So everything checked out for the Johnson Anderson family.
Well, I love the way you drew your diagram with the common ancestral couple at the top, and then, with the boxes coming down for each descendancy line finally until you get to your test takers, and then all of his matches there at the bottom. So great diagram, really easy to understand, really easy to comprehend. So then you also had the Johnson Clark family, which is James William Johnson and his second wife. And so that makes relationships a little bit different because they're going to be half relationships to JJ, your tester.
Yeah, so there were 3 matches that came from William Johnson and Dempsey Clark, and predicted half relationships will share smaller amounts of DNA than predicted full relationships because the shared DNA comes from one ancestor instead of 2. So all 3 matches shared an amount of DNA within the predicted range of a half relationship. So in this case, we had 2 half second cousins and 1 half second cousin once removed. And so I kept the name James because they descended from he and Dempsey. So James 5 shared 113 centimorgans. James 6 shared only 66 centimorgans. And then James 7, the second cousin once removed, shared 117 centimorgans. So this was an excellent example of random inheritance and just how we just get different amounts from different ancestors. So I diagrammed very similar to the last one with James and Dempsey at the top and then their matches coming down through their children. I then cross-referenced this diagram to the great group in the table, so everything checked out with the Johnson Clark family matches as well.
This is such a good reminder to check the half relationships that we may forget about or not think about.
Well, and they're so common. I mean, how many spouses didn't make it? And I've seen this in my own family, and they're so useful to separate out the different lines.
Well, I love that you were separating the diagrams into smaller diagrams so that they can be legible on the report page. I think so often we will make a huge diagram that's really wide and difficult to use in a report. So, this is just such a good example of how to break that up into different ancestral couples and then make it so that you can talk about the DNA evidence in pieces and show just parts of the diagram as you go along.
Yeah, it does make it definitely a little bit easier to digest little bits at a time.
Well, moving back in time, tell us more about the Alford Evans family connections.
So for the Alford Evans, then were James's hypothesized parents. They were proved through the documentary evidence, but to go a generation back and compare with his siblings, three matches were found who descended from Robert F. Alford and his wife, Alcie Evans. So I named the matches according to the sibling line that they descended from, and all of them shared an amount of DNA within the predicted range of third cousins. So the match through Rebecca was a third cousin once removed. She shared 35 centimorgans. Another match through Eveline's line, a third cousin shared 43 centimorgans. And Robert's line also produced a match, a third cousin who shared 69 centimorgans. And just like with the group before, two are closer to the average, one a little farther, but all within that predicted range. So this diagram was cross-referenced to the blue group in the table. So everything here checked out as well. And so it's just, taking each cousin group and testing them for the shared amounts is a way to cover a lot of relatives.
Yes, and I love how this generation is really the one that gives us that first Alford connection there.
Mm-hmm. Yeah, this was really fun. This was fun to see.
Yeah, you combined your chart then.
I combined them. So I took all the little ones and put them all together into one. Because sometimes it's nice to see how these parts fit into the whole picture. This showed how the autosomal DNA supported the hypothesized relationship between James Johnson and the Alford parents. So, again, just using color to differentiate the six matches who descended from James and the three matches who descended from the Alford siblings. I played with that one that, color can be useful, but too much can get confusing. So there's a right balance. So just play with it. And that's what's so great about Lucid Chart is you can try a few different things and see what you like. Something that helped me was just to kind of bracket the second cousin matches and the third cousin matches. It just helps me know what amount of DNA I should be expecting, and it just kind of helps with the whole tracking and keeping track of the information.
What did you do with shared matches?
So, shared matches is one of my favorite and most used DNA tools. I use it to create genetic networks. It also works well for splitting the networks, like we talked about the half relationships. You can kind of tease out other relationships strategically. And one of the ways that shared matches works, an example of that is JJ and his second cousin who I named James 5, both have JJ's third cousin Robert in their list of matches. So this makes Robert a shared match. So I took all of JJ's shared second cousin matches and put them in a table. I listed the second cousins on the far left column and shaded those blue. Then I listed third cousins in the top row and shaded those gray. I started with the second cousin at the top and went left to right across each row. I placed an X in the space under each third cousin who appeared in both JJ's list of matches and in his second cousin's list of matches. So rinse and repeat, going down the left column until all shared matches are marked with an X. So all the X's in the table form a genetic network or a cluster. This is the manual way to do it. There are lots of other tools that can do it, but with such a group, a small group, it was easy to do, and it helps solidify my understanding of what a genetic network is. Paul Woodbury explains the significance of genetic clusters in a family tree webinar titled Connecting the Dots, Introduction to Autoclusters at MyHeritage DNA. He stated, if several members of a genetic network group all descend from a known ancestor or ancestral couple, then it can be assumed that the other members of that group are also likely related through the same ancestral line. So for the Johnsons' case, JJ's shared matches provided strong evidence of a biological relationship between the Johnsons and the Alfords as members of his genetic cluster, who all likely descended from Robert, Alford, and Elsie Evans. So again, it all came together with autosomal DNA as well. I might mention, to satisfy genealogical proof standard, each parent-child link needs to be verified with documentary research. And this was done previously by the client. I didn't do this in the report, but they had done extensive research, and in their book, all these lines are documented. It was fun to get to combine all the work that they had done over time.
Yes, it's always nice to be able to bring it all together. And your table shows so nicely how all these different matches also shared with one another. It's great to have that genetic network.
Well, I love that you were able to go back even another generation and find matches to the Alford Tipton couple. Tell us more about that.
Right. So the Alford Tipton matches represented that next generation back in time. So these were fourth cousin matches on the paternal Alford line, who descended from JJ's third great grandparents, Charles Alford, and his wife, Elizabeth Tipton. So Charles and Mary had 7 children who provided excellent autosomal DNA coverage for this project. These matches came through 6 different sibling lines than JJ's. So one from each Alford sibling is represented in that colored table's green group. And a diagram shows the total number of matches through each sibling. I didn't do the full line down, but just how many matches came from each one, just for simplicity, that you can see there was some sharing there. And all matches shared an amount of DNA within that predicted range of fourth cousins. And this just added that strong evidence of biological relationship between the Johnsons and the Alfords at the next generation. So the GPS standard applies here as well, and all that research has been done. So this is typically as far back as you want to go with autosomal DNA. Although you can go back farther, the amounts get smaller and more difficult to trace because of so many relationship possibilities. And I know you've done a lot of that, Nicole, and Diana too. But in general, I would say for those starting out, cap it off here, and staying within there will help in the learning process. And then as you get to understand, then you can go further back. And of course, having those documented lines helps.
Love the table just showing how many matches come from each child of Charles Alford and Elizabeth Tipton. But it's so nice to have just a visual that there are a bunch of matches coming from this couple, but not have to have such an enormous diagram showing it.
Yeah, sometimes simple is just better. I love that. So then you also did the same process on the maternal Alford line, who came through the Evans and the Parks couple.
Right. So the Evans Parks matches, they were on the same generational level. These were fourth cousins that matched on the maternal Alford line. So they descended from another set of third great grandparents who were Patrick Henry Evans and Rebecca Parks. These were Alcee Alford's parents. Patrick and Rebecca had 3 children to compare autosomal DNA. So fewer matches came from this line, but still provided extra coverage. And they had 2 sibling lines that were represented. So I quite certain they had more children, but these were the lines who had tested and that we were able to use for this project. And to point out, Alcee's father's name is Patrick, and so that was another something to correlate naming patterns, and so that all makes sense with his name as well. These matches were represented in the colored table as the pink or the red on the blog. These matches also shared an amount of DNA within that predicted range of fourth cousins and added an additional layer of evidence to the biological relationship between the Johnsons and the Alfords again. And of course, the GPS standard applies here as well across the board. After a thorough examination of the autosomal DNA, I concluded that DNA matches at the second, third, and fourth cousin levels provided strong and sufficient evidence for a biological relationship between James William Johnson descendants and Robert and Alcee Alford descendants.
Wow, that's great. So you were able to go back a generation past the Alfords to both of the lines of the husband and the wife. So much great DNA evidence that really shows that JJ is connected to all of these Alfords.
Yeah, that was the fun proof. So you making that recommendation to him was just exactly what he needed, and how amazing to find all these cousins that he might not have known how they were related otherwise.
So much evidence coming together. Tell us how you did the conclusion for the project.
So I ended with this written conclusion. This research session successfully confirmed that James William Johnson was born Patrick M. Alford. The evidence contained in the paper clues of James and Patrick's fan club, together with DNA analysis, prove the biological connection between the Johnsons and the Alfords. The timeline of events in various records compared with their locations showed probability. These events, viewed through the lenses of historical and societal context, indicated why, and the geographical consideration of rivers, farmlands, and forests, incorporated with available travel and communication, shed light on how. So everything just kind of came together using those methodologies and that information to prove this case for James. And what an exciting discovery that they made and have been researching for a long time. They did so much work, and it was a pleasure to work with them. My tips and takeaways for using fan club research is to begin with an open mind. We were not there. We need to put ourselves in the context of our ancestors, and using logic and the GPS to reason through and put together a case for your ancestor will help if you just open your mind to the possibilities. So also consider name variations and patterns. For example, a shortened version of a given name, or the use of a middle name, nicknames, or renaming of loved ones. Also observe who and what is missing. Use negative evidence to your advantage. In the Johnson case, there was no record for Patrick after 1880, and there was no record for James before 1880. Elsie Jane was missing from her father's household in 1900, and the Johnson surname was missing from Y-DNA results. So all of these things helped indirectly prove as well. So if something is missing, take note about that. And then remember to click on my fan timeline in the blog post and start one for your research today. Good luck.
Great conclusion. I just love this project. So thank you for sharing it with us.
And for our listeners, if you want to go read the actual report that Michelle wrote, that is on the blog post number 3, and you can actually see how this was all written up, which is not an easy task. Doing the research can be really fun and exciting, but getting it written up is another story. So,
right.
Congratulations on getting it all together. Well, thanks, Michelle, so much for being on the podcast. It's been so fun to hear from you and to hear your process. Hopefully all of our listeners really learned from hearing how you broke this down, something very complicated and tricky.
Oh, thank you.
Thanks, everyone, for listening, and we'll talk to you next time. Bye-bye.
Have a good week.
Bye. Thank you for listening. We hope that something you heard today will help you make progress in your research. If you want to learn more, purchase our books, Research Like a Pro and Research Like a Pro with DNA on Amazon.com and other booksellers. You can also register for our online courses or study groups of the same names. Learn more at familylocket.com/services. To share your progress and ask questions, join our private Facebook group by sending us your book receipt or joining our courses. To get updates in your email inbox each Monday, subscribe to our newsletter at familylocket.com/newsletter. Please subscribe, rate, and review our podcast. We read each review and are so thankful for them. We hope you'll start now to research like a pro.